Okay, so yeah, this one's going to have some art challenge to it. So let's look at level sets of this function f is x plus y plus e to the z. By the way, this is another one of these problems where we're going to be combining stuff from 2.4 with stuff from like 2.2. And here we go. So let's look at the level set where we set the function equal to c. Well, I have x plus y plus e to the z is equal to c. Okay. I have no idea what that looks like. So how do I tell what something looks like? If I want to look at the solution set to an equation, well, I have techniques. It's section 2.2. I could see, maybe we get lucky if this is a rotation. No, it's not a rotation. Is this a translation or a stretch or something of something nice? And no, it's not. Yeah.
All right, I got a general question. So
yeah.
You could use rotation and like cross sections for different constructions. I thought you could only use graph constructions. Like you could only use cross sections and like.
All that business in 2.2, you know, came before we even said the word graph or level set or parametric. I mean, so those are techniques for understanding solution sets to equations. Yeah, and you know, if you take a function and look at its graph, you're looking at a particular equation. If you have a function and you're looking at a level set, which is what we're doing here, then you're looking at a particular equation. And so all equations are susceptible to the techniques from 2.2. Yeah, absolutely. And that's what we're going to do here. Here I've got, you know, as part of looking at a level set of this particular function, I have found myself faced with an equation, and 2.2 is all about how to figure out what solution sets to equations look like. So here, the only technique that from 2.2 that has a chance of working, I think, is cross sections. So, all right, so let's start taking cross sections. Maybe I'll set, I don't know, x equal to some constant k. Let's see what these things look like. Well, set x equal to k, I'm going to get k plus y plus e to the z equals c. Let's rewrite this as y equals, I've got some constants, c minus k, and then minus e to the z. So this is not that bad, right? It's so one variable is a constant minus an exponential of another variable. So that we can kind of draw a picture of, and let's take a whack at it. So let's see here. Y.
What's your reason for allowing you to set x equal to k?
Because I've got an equation here, and I'm going to figure out what it looks like by taking cross sections of it.
Oh, so you're doing the cross sections.
Mm-hmm. That's right. That's right. Exactly. So now specifically, because I'm setting x equal to k, everything that I come up with is going to be in this plane here. Right? That's a plane where x is equal to k. Does that make sense?
It's a level set.
Setting x equal to k. Well, yeah, forget about, we're looking at this level set. Sure, right? So we've set f equal to c. This is the equation we're interested in, and we're going to spend the rest of this page probably, looking at this one equation representing this one level set of that function. Yeah. Okay. So
this is all in the y-z plane?
It's not in the yz plane. It's in the plane x equals k, which is parallel to the yz plane.
Okay.
Yeah, that's right. That's right. So yeah, so within this plane, you know, x equals k. Yeah, that right there is kind of what you might casually call the y. I mean, that's the direction y goes, and this is the direction z goes, right? Okay, so let's draw this picture. Well, y is a negative exponential of z, but we've got this c minus k out here. So I claim roughly what we're going to have is something kind of like this. Make sense? So as z gets higher, larger values of z, this gets increasingly large, which takes us increasingly away from this fixed, you know, this little dotted line there maybe is y equals c minus k. That's just that little sort of guideline, and then the exponential tells us how far our actual curve deviates from that. So that's what our cross-section looks like. Now, the good news is that we're actually a large fraction of the way towards being done. I mean, the good news is we just don't have that much more to draw. Because what if I wanted to look at a different cross-section perpendicular to the x-axis? Well, all that's going to do is give me a different k, and that's just going to make this little guideline move. So if I increase k, that's going to decrease the value here, which means that, sort of like over in this direction. C is nowhere on the picture. C is it's a number it's the number that represents which level set we're looking at. But for the moment, C is a constant.
So what's the dotted line then?
This dotted line is, I notice that this equation looks a lot like this equation except for this exponential. And so I drew this first because it's easy. It's just a straight line, y equals c minus k, sitting inside of that cross-section. And then I subtract the exponential to get the actual curve I care about.
Okay.
Yeah. Okay. So now, the picture that I'll get if I look over here at a different value of k, when k increases, again, this number decreases, which just means that dotted line moves over. And now maybe it's like over here. And again, I have a little exponential like that.
So it's moving towards us?
Yeah, as the cross-section moves toward us, the cross-section of the surface we're interested in moves to the left. And I bet you can almost kind of even see what this thing looks like right now. I claim that I'm going to draw the whole thing now, what this level set looks like. It's kind of a folded over piece of paper. Like that. Right. And its cross-section at one value of k.
That's all along the x-axis. Like that folded piece of paper.
I'm sorry?
It's like this along the x-axis?
It's not parallel to the x-axis, it's sort of tilted. Right? Because as you come out, away from the YZ plane, then that k is increasing, which means this whole thing here is moving to the left. So it's not parallel to that. It's like parallel to some line like that I didn't draw very well.
Can you explain again why it's moving to the left?
Yeah, because as we move out, k increases. If k increases, this number decreases, which means the value of y decreases. So this whole thing shifts to the left. Yeah. Exactly. So good news, we've got a level set. This is what our level. Now, I didn't take cross sections perpendicular to the y-axis or the z-axis because I didn't really need to. I can already kind of see, we've got little exponential little sort of flop overs to the left that are moving to the left as we come out of the page, and that gives me this picture. So that's one of these level sets. And in fact, this is most of the level sets. Most of the level sets can look kind of the same because what happens if I change C? Well, if you change C, that's just going to change this value here. Right? So as C increases, for example, that's just going to take all of these cross sections and move them to the right. So that's just going to give you like level sets that were sort of more like that.
So that's as C increases.
That's as C increases, yeah. So this might be, some value of C, then this here is a second value of C, and this is maybe a third value of C,
K
etc.
stays the same.
Now K depends. K indicates which cross section of one of these level sets you might be looking at.
Oh, okay.
Yeah, so there's lots of different values of K. Yeah, right. Exactly. Yeah. So yeah, this is an art challenge, but there's a lot of stuff that goes into this problem. Understanding what a level set is, understanding what a cross section is, interpreting cross sections, and of course then the being able to draw it is a bit of a challenge. But in fact, let me adjust that statement. The drawing wasn't really the hard part. The hard part was taking these cross sections and using your geometric intuition to figure out what does that really look like. And once you see that it's like a folded over piece of paper. You know, I don't have quite enough room there, but it's just, you know, the actual drawing of it's not so bad. Okay. So there's your representative collection of level sets.